For centuries, humans dreamed of flying. The idea of soaring through the skies like birds has been a part of human imagination since ancient times. From the myth of Icarus to Leonardo da Vinci's sketches of flying machines, the desire to conquer the skies has always been a powerful force driving human innovation. Early attempts like the Wright brothers' first flight in 1903 used propellers to achieve lift. Their success marked the beginning of a new era in aviation, proving that controlled, powered flight was possible. The Wright brothers' meticulous experimentation and engineering laid the groundwork for future advancements in aircraft design. But a new idea was taking shape: jet propulsion. Unlike propeller-driven aircraft, jet engines promised greater speed and efficiency. The concept of using jet propulsion to power aircraft began to gain traction among engineers and inventors in the early 20th century. The first jet engine, a rudimentary design, was created in 1910 by Romanian inventor Henri Coanda. Coanda's design was revolutionary, but it was ahead of its time and did not lead to immediate practical applications. However, it laid the foundation for future developments in jet propulsion technology. It wasn't until the late 1930s that a practical jet engine was built. During this period, significant advancements in materials and engineering techniques made it possible to create more efficient and powerful jet engines. These developments were crucial in transforming the theoretical concept of jet propulsion into a practical reality. Sir Frank Whittle in England and Hans von Ohain in Germany independently developed working jet engines. Whittle's and von Ohain's contributions were pivotal, as they both managed to overcome numerous technical challenges to create engines that could be used in actual aircraft. Their work marked a significant milestone in the history of aviation. These inventions would change aviation forever. The introduction of jet engines revolutionized air travel, making it faster and more efficient. The impact of this technology extended beyond military applications, eventually transforming commercial aviation and making air travel accessible to millions of people around the world. The first jet-powered flight using von Ohain's engine took place in Germany on August 27, 1939. This historic flight demonstrated the potential of jet propulsion and set the stage for further advancements in jet technology during the following decades. World War II accelerated jet development, leading to the creation of the Messerschmitt Me 262, the first operational jet fighter. The intense demands of the war spurred rapid innovation and development in jet technology, resulting in aircraft that were faster and more powerful than ever before. The legacy of these early jet engines continues to influence modern aviation. Jet engines are marvels of engineering. They work on a simple principal thrust. Air is sucked into the front of the engine by a powerful fan. Inside the engine, the air is compressed and mixed with fuel. This mixture is ignited in a combustion chamber. The burning gases expand rapidly, creating a powerful force. This force pushes the gases out the back of the engine at high speed, creating thrust. This thrust propels the aircraft forward. Different types of jet engines exist, but they all operate on this basic principle of sucking in air and expelling it with greater force. The advent of jet engines revolutionized air travel. Jets could fly higher, faster, and farther than propeller-driven aircraft. This made long-distance travel faster and more accessible. The de Havilland Comet, introduced in 1952, was the world's first commercial jet airliner. It ushered in the jet age, a period of rapid growth in air travel. Air travel became more affordable, opening up the skies to the masses. Today, millions of people fly every day, connecting distant corners of the world. Jets have shrunk our planet, making it possible to travel across continents in a matter of hours. Jet engines also had a profound impact on military aviation. The introduction of jet engines revolutionized the way wars were fought, providing unprecedented speed and power to military aircraft. This technological leap allowed for rapid advancements in aerial combat tactics and strategies. Jet fighters, faster and more maneuverable than their propeller-driven counterparts, dominated the skies. These jets could reach altitudes and speeds that were previously unimaginable, giving them a significant advantage in dogfights and air superiority missions. The agility and speed of jet fighters made them a formidable force in any conflict. The Cold War spurred a rapid development of jet technology. Both the United States and the Soviet Union invested heavily in their air forces, leading to a technological arms race. This period saw the creation of some of the most iconic military jets, such as the F-4 Phantom and the MiG-21. These aircraft were not only faster and more powerful, but also equipped with advanced avionics and weaponry. Military jets became increasingly sophisticated, equipped with advanced radar, missiles and electronic warfare systems. Modern jets are capable of performing a wide range of missions, from air-to-air combat to ground attack and reconnaissance. The integration of cutting-edge technology has made these aircraft highly versatile and effective in various combat scenarios. The quest for speed led to the development of supersonic aircraft, capable of flying faster than the speed of sound. Breaking the sound barrier was a significant milestone in aviation history, opening up new possibilities for military and civilian aviation. Supersonic jets such as the F-22 Raptor and the Eurofighter Typhoon continue to push the boundaries of speed and performance. The North American X-15, an experimental rocket-powered aircraft, holds the record for the fastest speed ever reached by a manned aircraft, reaching Mach 6.7, which is 4,520 miles per hour. This remarkable achievement demonstrated the potential of rocket propulsion and paved the way for future advancements in high-speed flight. The legacy of the X-15 continues to inspire new generations of aerospace engineers and pilots. One of the most remarkable phenomena associated with jet aircraft is the sonic boom. This phenomenon occurs when an aircraft travels faster than the speed of sound, which is approximately 343 meters per second, or 1,235 kilometers per hour at sea level. The sonic boom is not just a single event, but a continuous effect that occurs while the aircraft is traveling at supersonic speeds. When an object travels faster than the speed of sound, it creates pressure waves in the air. These pressure waves are compressed together because the object is moving faster than the waves can propagate. This compression of air molecules forms a shock wave, which is a sudden change in pressure. These waves combine to form a shock wave, which creates a loud, thunderous noise known as a sonic boom. The intensity of the sonic boom depends on various factors, including the size, weight, and speed of the aircraft, as well as the altitude at which it is flying. The shock wave can be heard as a double boom caused by the nose and tail of the aircraft. Sonic booms can be startling and disruptive, hence supersonic flight is often restricted over populated areas. The noise can cause damage to structures and disturb people and animals. To mitigate these effects, regulations are in place to limit supersonic flight to certain areas, such as over oceans or uninhabited regions. Another interesting phenomenon is the vapor cone that sometimes forms around aircraft flying at high speeds. This visual effect, often seen as a cone-shaped cloud, occurs when the aircraft is traveling at transonic speeds, which are speeds close to the speed of sound. This cone is not actually a cloud of vapor, but rather a condensation cloud formed by a drop in air pressure and temperature. As the aircraft approaches the speed of sound, the pressure around it decreases, causing the temperature to drop and moisture in the air to condense into tiny droplets, creating the visible vapor cone. This phenomenon is a testament to the fascinating interplay of aerodynamics and atmospheric conditions. Jet aircraft come in a wide variety of shapes and sizes, each designed for a specific purpose. The Boeing 747, affectionately known as the jumbo jet, revolutionized air travel with its massive size and long-range capabilities. On the other end of the spectrum are stealth aircraft, such as the Lockheed F-117 Nighthawk and the Northrop Grumman B-2 Spirit. These aircraft are designed to be virtually invisible to radar, making them ideal for covert operations. Each jet aircraft is an engineering marvel, a testament to human ingenuity and our relentless pursuit of technological advancement. The future of jet technology is full of possibilities. Researchers are exploring new engine designs such as scramjets and ramjets, which promise even greater speeds and efficiency. Hypersonic flight, defined as speeds above Mach 5, is no longer a distant dream. Several countries and private companies are actively developing hypersonic aircraft, which could potentially revolutionize air travel and space access. Imagine flying from New York to London in under an hour, or launching satellites into orbit at a fraction of the current cost. And while jet engines have brought about remarkable progress, we must also acknowledge their environmental impact. Jet engines consume large amounts of fossil fuels and release greenhouse gases into the atmosphere, contributing to climate change. The aviation industry is actively seeking ways to reduce its environmental footprint. This includes developing more fuel-efficient engines, exploring alternative fuels, and optimizing flight routes to minimize fuel consumption. From the Wright brothers' first flight to the sleek, supersonic jets of today, our fascination with flight has only grown stronger. Jet engines, with their ability to propel us through the air at incredible speeds, have shrunk our world and expanded our horizons. As we continue to push the boundaries of technology, the future of jet-powered flight promises to be even more exciting and transformative.